In this walkthrough, we are going to investigate an IIS 504 gateway timeout from the point of view of an application support analyst. A 504 error can be misleading. It is easy to assume that IIS has failed, or that the fix is simply to recycle the application pool or increase a timeout value. Sometimes that may provide temporary relief, but it does not explain why the request exceeded the timeout threshold in the first place. The goal of this walkthrough is to follow the evidence properly. We will start with the user visible symptom, identify the failing URL, check IIS logs, correlate the request to the application logs, inspect backend SQL activity, apply targeted fix, and then validate the result. This is the kind of structured investigation that separates a temporary workaround from a credible root cause analysis. The incident starts with a simple user report. The month-end dashboard is returning a 504 gateway timeout. That user report gives us the symptom, but not the cause. At this stage, we should avoid jumping to conclusions. A 504 usually means that a gateway, proxy, or load balancer did not receive a response from the upstream service in time. The upstream service may be IIS, the application, SQL server, an external API, or another dependency behind the application. The first support task is to capture the facts. We need the affected URL, the time of the error, the affected user or customer, whether the problem is repeatable, whether it affects everyone or only some users, and whether it started after a deployment or configuration change. Good incident handling starts with scope and evidence, not guesses. A 504 gateway timeout is not the same thing as a direct application error. In a typical web stack, the browser talks to a gateway, reverse proxy, firewall, or load balancer. That gateway forwards the request to IIS. IIS passes the request into the application, and the application may then call SQL Server, APIS, file shares, reporting services, or other dependencies. A 504 is normally returned when the gateway gives up waiting for the upstream layer to respond. That means IIS might still be processing the request even after the user has already seen the timeout. This is why logs can appear confusing. The gateway may show a 504, while IIS may show a long-running request, a delayed 200 response, or a different backend status. The job is to line up the evidence across layers. Before changing settings or recycling anything, we need to build the incident picture. The minimum evidence set is the failing URL, the approximate time window, the affected user or customer, the client IP where possible, the IIS server, the application pool, and whether the issue is intermittent or consistent. We also check for recent changes. Have there been a deployment, a configuration change, a database maintenance job, a certificate renewal, a firewall change, or a report release? This does not prove cause, but it helps focus the investigation. For this walkthrough, the affected URL is _portal reports per month end _ the incident time is around 9:15, the application pool is _SupportDesk portal app pool _ and the IIS server is _WEB01 . From here, we follow the trail into the logs. In a real support incident, we normally do not start with a request ID already known. We usually start with a user report, a monitoring alert, or a browser error. In this example, the user reports that the month-end dashboard is returning a 504 gateway timeout at around 9:15. The first thing to capture is the exact failing URL, the approximate time of failure, the affected user, and ideally the client IP or customer site. That gives us enough information to search the IIS access logs. In the IIS logs, we look for a matching request by URL, timestamp and client IP. Here the failing request is for _portal reports per month end _ and the log shows a 504 response with a long duration of 91,342 milliseconds. That duration is important because it tells us the request was not failing instantly. It was waiting long enough to hit a timeout threshold. Once we have the IIS log entry, we then move into the application logs. The application log gives us something the URL alone cannot give us, a unique request ID. In this walkthrough, that request ID is _REQ20260517091500042 _ Some applications may not give a request ID in the logs. Before using that ID for deeper diagnosis, we validate the correlation. The URL, timestamp, user and client IP should all line up. If they do, we now have a reliable trail to follow. That request ID becomes the anchor for the rest of the investigation. We can use it to connect the IIS evidence to application logging, SQL activity, external API calls, tracing, and infrastructure events. The IIS access log is usually one of the best first technical checks because it confirms what IIS received and how long the request took. In this example, we search the IIS log for _portal reports per month end _ around the incident time. The key fields are the date and time, client IP, HTTP method, URI stem, status code, substatus, Win32 status, and time taken . The important value here is time taken . Before the fix, the request duration is 91,342 milliseconds, which is just over 91 seconds. If the upstream gateway timeout is 60 seconds, this tells us the request exceeded the gateway threshold. The log entry confirms that we are investigating the right URL and the right time window. It does not yet prove why the request was slow. It tells us where to look next. If the incident is happening now, we can inspect IIS while the request is still active. Using _appcmd_, we can list worker processes and active requests. The aim is to confirm whether the relevant application pool has long-running requests and whether those requests map to the failing URL. In this scenario, the application pool is _SupportDesk portal app pool and the worker process has PID 6428. The active request shows _portal reports per month end running longer than the gateway timeout. This is useful because it separates a quick rejection from a slow backend operation. The request is not failing immediately. It is being processed for too long. At this point, recycling the app pool might clear the symptom, but it would also destroy the evidence. Capture the active request details first. Now we connect IIS evidence to application-level evidence. Failed request tracing, application logs, or structured logging can show what happened inside the application for that request. We look for the same time window, user, URL, and request ID. The useful point here is correlation. IIS tells us that the request was slow. The application log can tell us what the application was waiting for. In this walkthrough, the application log shows that the request entered the application and spent most of its time waiting on the month-end dashboard data load. That does not automatically prove SQL is the cause, but it makes SQL the next sensible place to check. The request ID is now our investigation anchor. It keeps the evidence joined together instead of treating each log source as a separate story. The next step is to check SQL Server while the request is active, or to use historical monitoring if the request has already completed. In this example, we query SQL Server DMVs to look for active requests from the application login. The relevant session is SPID 78, coming from WEB01 using the login IIS app pool, SupportDesk portal app pool . The SQL text shows that the application is executing dbo.usp_get month-end dashboard . The elapsed time is over 82 seconds, with high reads and a wait pattern consistent with expensive data access. This is the first strong technical link between the 504 and the backend dependency. The web request is timing out because the application is waiting for SQL to complete. We now move from symptom investigation into root cause analysis. Now we inspect the stored procedure used by the failing page. The procedure filters invoice posting data by status and posting date for the month-end dashboard. That filter pattern matters because the database needs an efficient way to find the relevant rows. The test execution shows very high logical reads before the fix, 1,248,920 reads, with an elapsed time of 82,417 milliseconds. That is far too slow for a web request sitting behind a 60-second gateway timeout. The important support analyst point is not just, SQL is slow. The question is why it is slow. In this case, the filter pattern does not have the right supporting index, so SQL Server is doing far more work than necessary. That gives us a specific, testable fix. We are assuming that the index was the issue in this case, so we add an index to the posting date. See other videos for index troubleshooting. The fix is to add a targeted non-clustered index that supports the procedure's filter pattern. In this example, the useful access path is based on _status and posting date with included columns needed by the dashboard query. This is not a random index. It is designed around the query pattern that caused the timeout. After applying the index in the lab, the procedure is retested with the same parameters. The elapsed time drops from 82,417 milliseconds to 2,184 milliseconds, and the logical reads drop from 1,248,920 to 14,806. That is the difference between a request that times out and a request that completes comfortably within the gateway threshold. In production, this would still need normal change control, testing, and review. But the principle is clear: fix the bottleneck rather than hiding it. After the fix, we validate at multiple layers. First, rerun the failing URL and confirm that the user visible 504 no longer occurs. Then check the IIS log to confirm the request duration has reduced. In this example, the request now completes in 3,126 milliseconds and returns 200 OK. Next, validate SQL. The stored procedure now completes in about 2.2 seconds with far fewer reads. That proves the fix improved the backend dependency, not just the browser symptom. Finally, check monitoring and user confirmation. There should be no new 504 errors for the same URL, and the affected user should be able to open the month-end dashboard successfully. Good validation proves both technical recovery and user impact recovery. After the fix, we validate at multiple layers. First, rerun the failing URL and confirm that the user visible 504 no longer occurs. Then check the IIS log to confirm the request duration has reduced. In this example, the request now completes in 3126 milliseconds and returns 200 OK. Next, validate SQL. The stored procedure now completes in about 2.2 seconds with far fewer reads. That proves the fix improved the backend dependency, not just the browser symptom. Finally, check monitoring and user confirmation. There should be no new 504 errors for the same URL, and the affected user should be able to open the month-end dashboard successfully. Good validation proves both technical recovery and user impact recovery. The reusable checklist is the main takeaway for application support teams. Start with scope, who is affected, what URL is failing, when it started, and whether it is intermittent or consistent. Then collect evidence, browser error, gateway logs, IIS logs, application logs, event logs, monitoring data and recent changes. Next, inspect live behavior if the issue is active. Look for long-running IIS requests, app pool health, worker process state, connection pool pressure, CPU, memory, and backend dependencies. Then follow the evidence to the likely dependency, SQL, API, file storage, authentication, reporting services, or infrastructure. Only after that should you apply the fix, validate it, communicate the outcome, and document the incident. The checklist is designed to stop support teams from jumping straight to the most familiar workaround. The key lesson is that a 504 gateway timeout is a symptom, not a root cause. The visible error may appear in the browser, but the actual delay may be in IIS, the application code, SQL server, an external API, or another infrastructure layer. The professional support approach is to follow the trail: user report, failing URL, IIS logs, application logs, request ID, backend dependency, fix, validation and communication. In this walkthrough, the root cause was a slow SQL procedure behind the month-end dashboard. The correct fix was not simply to increase the gateway timeout. The correct fix was to identify the expensive backend operation, tune it, and prove the request completed within the expected threshold. That is the support desk approach: evidence first, safe diagnosis, targeted resolution, and clear communication. For more practical support desk walkthroughs, templates and troubleshooting packs, follow Support Desk.